Now, with scientific notation, we can multiply two um, set of factors where it's written in scientific form, and we can multiply those factors. Now, what we're going to do here is combine our like parts. So, our like parts, we're looking at the scientific part, the decimal part, excuse me, and also the exponential point part. So, we're going to combine 5 and 2.8 by multiplying, and then we have times 10 to the 12th times 10 to the negative 5. Now we're going to multiply 5 and 2.8 just like we would multiply any number in decimal number. And we have here 14 times, and then 10 to the 12th times 10 to the negative 5. Remember our exponent rules where we're going to add the exponents. So you're saying here 10 to the 12 plus negative 5, add those together. We have here 10 to the 7th power. Now, ask yourself, does our answer follow the rules of the rule of scientific notation? Because remember, the rule for scientific notation, this A part must be between 1 and 10, where it says a number that is less than 10 but at least 1. And right now, 14 is not between 1 and 10. So we're going to take this 14 and we're going to convert 14 into scientific form. Meaning, I want this 14 to be a decimal number that's between 1 and 10. So our 14, here's the decimal point right here. After the 4, we're going to move it over one space to the right. So our 14 becomes 1.4 times 10 to the, and we only move once, and it's going to be positive 1 because 14 is greater than, is a positive number, greater is a large number that's greater than 10. So this is us converting 14. Now what we're going to do is bring down the 10 to the 7th, and then the exponential part here, we're going to add the exponents, 10 to the 1 plus 7, and that will give us here our final answer of 1.4 times 10 to the 8th power. So don't forget, our scientific, this decimal number needs to be between 1 and 10. If it's not, you're going to have to convert that number again. All right, so that's multiplying. Let's look at dividing. We have here, we're going to divide 2.8 times 10 to the negative 14 all over 7 times 10 to the 9th. So we're going to combine like parts, 2.8 over 7, then times 10 to the negative 14 over 10 to the 9th. Let's divide 2.8 by 7, which gives us 0.4. And then 10 to the negative 14th all over 10 to the 9th. This is our quotient rule where we're going to subtract the exponents. So you're saying 10 to the negative 14th minus 9, and 10 to the negative 14th minus 9 gives us 10 to the negative 23. Now, in scientific notation, it's okay if I answer, or excuse me, if our exponent is negative, because that's the rule that our exponent can be positive or negative. So this component, the base 10 component, is okay. Let's look at the 0.4. Is 0.4 between 1 and 10? Yes, it is. So our final answer, because 0.4 is between 1 and 10, we can, well, let's think about it before I say that. 0.4. No, it's not. So we're going to have to convert this 0.4. Because think about it, if we think about it in terms of coins or money, let's say that this 0.4 is 40 cents. Well, is 40 cents between $1 and $10? No, it's not. So we're going to have to convert. So this 0.4, we're going to move the decimal point over one space to the right. And then this becomes 4 times 10 to the negative 1 power. And because it's negative 1, it's because this 0.4 is less than 1. Bring down the 10 to the negative 23. Your exponential component, 10 to the negative 1 times 10 to the negative 3. Add the exponents. And our answer is 10 to the negative 24 power.